Now let's look at some examples of applying exponent rules. Well, the first thing is here are the exponent rules that we're talking about, and these are written as examples, not in symbolic form. If you need some help with these rules, then there's two videos. One's called Exponent Rules Part 1 that goes through, I think, the first 4 or so, and then Exponent Rules Part 2. And then there are some examples there, but I'd like to do some more examples. So the first example that I would like to look at is 5x to the minus 2, y to the 4th to the minus 3. And all of these should say, just simplify. The directions usually are straightforward. And then if we think about this, here we have a parentheses and a power outside the parentheses. So that's simply this rule right here where we have, actually that's the wrong rule, sorry. That's just this rule right here, rule number 3. We have things that are inside the parentheses, so that means we take this power and we apply it to everything that's inside the parentheses. So the first step that I would do is that's 5 to the minus 3 times x to the negative 2 raised to the minus 3, y to the 4th times minus 3. Now 5 to the minus 3, right? 5 to the negative 3, that's 1 over 125. Another way to say that is that's 1 over 5 to the 3rd. And then we can simplify it in the next step, 1 over 125. Now, x to the negative 2 raised to the negative 3, you multiply the minus 2 times the minus 3, that's a positive 6. And here you have y to the 4th raised to the negative 3, then you multiply the 4 and the negative 3, that's negative 12. Now you could say this is just this, but I actually have to do it a slightly different way. At this point, we have things that are going to be in the numerator and the denominator. We need to figure out what goes well. This is 5 to the 3rd in the denominator, so that's 125 in the denominator. X to the 6th, that's a positive power, so that goes to the numerator. And y to the negative 12 means it's in the denominator. And there's your final answer there. So what you do is you just start, you work the problem. You start with the problem and then you successively apply the rules. How do we know what order to go in? Well, it's just PEMDAS, right? We go exponents first, right? Then, so you apply the exponent. Now here we have an exponent here, an exponent here, an exponent here, and then you have the multiplication. So now let's do another example. Let's do a problem, let's do 10 x to the 3rd y to the 5th over 18 x y to the 7th, right? So the trick here is, the first thing I would look at is see if you have any negative powers here. You don't have any negative powers here, and you don't have any powers to the power, so that I would just start simplifying. The 10 and the 18 you can simplify. 10 and 18, let's think what goes into 10 and 18. 2 goes into both. Does 4? No, 2 goes into both of them, so that'll be a 5 and a 9. Now you have x3 over x. If you're ever not sure, x3 over x, that's x times x times x over x, and one of the x's cancel with the other x's. Another way to say that is this is the power of 1, so that's 3 minus 1, so that's x squared. And then you have y5 over y7. You can do that two different ways. You can go y5 over y7 is equal to the y5 minus 7, which is y to the negative 2, which means the y2 will be on the bottom. Second way you can say, so if you have 5 y's on the top and 7 y's on the bottom, the first 5 y's cancel, you end up with 2 left, and the 2 that you end up having left over are going to be in the denominator. So then you just think about, well, what do I have left? I have 5x squared in the numerator. In the denominator, I have 9y squared. Now let's contrast that with a slightly different problem. Let's say we had 18x to the 3rd y over, let's say y to the minus 1 over 9x to the minus 4y to the minus 2. The first thing I would do in a problem like this is clear all the negative exponents. So I would rewrite this problem. If it has a positive exponent, I'd leave it where it is, 18 x to the third. Now y to the negative 1 means you have a y on the bottom, y to the negative 1 on the bottom in the denominator. Let's look here, we have a 9 here. X to the minus 4, a negative 4 means it's in the denominator, but it's already in the denominator, so it's in the denominator. The easiest way to think of that is if it has a negative exponent, it goes in the other place. So in this case, it goes to the numerator. And then same thing here, y to the negative 2. So literally, 1 over y to the minus 2 is 1 over y squared. But an easier way to think about it is this is in the denominator, but has a negative exponent, so it should go in the place that it's not. So it should go in the numerator. So that's a y squared there. Then I would simplify the numerator. And that would be 18 x to the 7th, right? Because it's x3 times x4, y squared over 9y. And let's see what simplifies. The 9 and the 18 cancel, and that becomes a 2. The y and the y squared cancel. Let me rewrite that since I made a slight mistake. We have this problem. The 9 and the 18 cancel, and that becomes a 2 and a 1. The y squared and the y cancel. You end up with 1y in the numerator. And your final answer is 2x to the 7th y over 1, or just 2x to the 7th times y. Let's look at one more example. Let's do 2x to the third times 3y over 20x5y minus third. Let's first simplify this, right? That's 2 to the third, x3 to the third. If you do that in your head, that's fine. Times 3y over 20x to the fifth y to the minus 3. I'm going to go, that's x to the 9th, so that's 2 to the third is 8. That's 8 x to the 9th times 3y, 20x to the 5th. Now at this point, it doesn't necessarily matter when you do this. I would probably do it at the very first step of the problem. But you have y raised to the power of negative 3. So I'd clear the negative exponent. The way you clear the negative exponent is if it's in the numerator, you put it in the denominator, and if it's in the denominator, put it in the numerator. So you put that y to the third up there. Now you just simply multiply across. 8 times 3 is 24. X to the 9. Y to the third, y times y is y to the fourth. The denominator is 20x to the fifth. Now see what I can cancel. 20 and 24, 2 goes into both of them. That would be 12 and 10, but actually 4 goes into both of them as well. So that would be a 6, and that would be a 5. We have an x to the 9th in the numerator, x to the 5th. That's either, you can think of that as x9 over x5 is equal to x to the 4th. Or you can think about there's 9 x's on the top and 5 on the bottom. 5 of them cancel, and you still end up with 4 on the top. However you think about that, those are equivalent answers. And then we just multiply across. You end up with 6x to the 4th, y to the 4th, over 5. And that's how you simplify expressions using the rule of exponents.